Hi, I'm Bryan Hed. I am a plant pathologist for Penn State University. I work at the Lake Erie Regional Grape Research and Extension Center, and that's located in Northeast Pennsylvania. We do grape research at the research station. It's part of the Ag Experiment Station for Penn State University. Been in business for, since about the 1940s. Doing grape research primarily for the Lake Erie region, but actually for the entire state. We have juice grapes and wine grapes that we work with. As the plant pathologist, of course, I'm working with disease management. My disease management program has been primarily based on the reduction of synthetic pesticides through cultural treatments, alternative materials for pest and disease management, that sort of thing. We traditionally have done fungicide efficacy tests. We generally do those every year, where we take new pesticides out on the market, we compare them to some of the older ones, some of the standard ones. Quite often we are testing alternative materials to see how they compare with the newer synthetic materials, some of the older synthetic materials, the standard materials, and that sort of thing, to see if we can basically introduce some alternative pesticides into existing programs, maintaining disease control, not sacrificing disease control in order to reduce synthetic pesticide use. Part of what's driving this, of course, is public concern for pesticide residues on foods and so forth. Some of the other work we do deals with cultural production methods that can be used to reduce some of our inputs, our pesticide chemical inputs. One thing in particular I've been working with is a leaf removal treatment. Leaf removal in the fruit zone is a very standard treatment, long practice treatment in wine grape culture in particular, not in juice grapes, but in wine grapes. We've been looking at varying the timing of leaf removal in order to perhaps be able to adjust our fungicide programs. We found that the earlier we remove leaves, the better reduction in disease pressure we're able to achieve with things such as bunch rot, which is a rot that occurs toward the end of the season during the ripening period. And if we can achieve a reduction in disease pressure, disease susceptibility through cultural treatments, then perhaps the idea is that we can reduce pesticide use. And in some cases we have been able to do that. Unfortunately, right now it's still on an experimental level, and we have not been able to really test this in commercial vineyards just yet. We have looked at the early leaf removal in commercial vineyards along with a typical spray program for growers and found some benefits from it. Also at the research lab, we've been testing different varieties for their fitness in Pennsylvania, particularly in northwestern Pennsylvania. We tend to be, of course, a bit colder in terms of winter conditions than the rest of the state. Recently we just concluded a variety trial looking at 18 different grape varieties for their ability to not only survive in our climate, but also to produce a quality juice and of course wine. In the future, we'll continue to look at new and existing cultural treatments and try, I think, to integrate as many non-chemical methods into grape disease management programs. In particular, we've been looking at a gibberellin spray, which seems to show some promise in terms of reduction in fruit set and bunch rot susceptibility, particularly in wine grapes and only in certain varieties. But it's still experimental. And of course, the material is not lawful to use in all cases. More research needs to be done in order to look into the ways in which that material, that gibberellin, affects different grape varieties differently. And of course, we'll continue with our perennial tasks of testing fungicides, which we will always do. It's always been one of the main things that we look at the research lab.